Trigonometry insights, understanding the basic concepts of trigonometry. Here we're going to talk about some of the basic identities. Trigonometry involves using the property of similar triangles having pairs of corresponding sides with the same ratio. So if I have a triangle, and we usually in trig start with the unit triangle where the radius is 1, we would call this direction x and this direction y, this being a right angle. Then any triangle with this angle A that is also can be thought of as a right triangle with right angle here, this angle D would have to have the same measure as this angle B. So we would have similar triangles. And so the ratio of these sides, which we will call, looking on the larger one, it's easier to see, x, y, and or, we can make a ratio. And the ratio of two of these sides for the big triangle would be the same as the same ratio for the corresponding sides of the smaller triangles. So if we use x as the adjacent, the side adjacent to the angle, one touching the vertex of the triangle, y is the side opposite or across from the vertex. And we can use find or using the Pythagorean theorem, r squared is x squared plus y squared. We have 6 basic identities. The sine is opposite over the hypotenuse, y over r. The cosine is the adjacent, x over r. The tangent is the opposite over the adjacent, y over x. The cotangent, x over y. The secant, r over x. And the cosecant, r over y. So we have these 6 defining relationships between the angle and the sides of the triangle, the right triangles. For angles along the axis, one side of the triangle goes to 0. That's not really a problem. We would consider that a degenerate triangle, and we would have, say, if it goes down to the x-axis, r and x would be the same and y would be 0. Or if it goes to the y-axis, x would be 0 and y and r would be the same. It can be handled in the same manner. The problem is, in some of those cases, some of the identities will end up with a division by 0, which means they're undefined for that angle. As long as the functions are defined, no division by 0, the chart makes it obvious that 3 of the functions are reciprocals of the other 3. So the sine is 1 over the cosecant. The cosine is 1 over the secant. And the tangent is 1 over the cosine. So we call these the reciprocal identities. The meaning of co, C-O, well, think of it as a prefix actually, means complementary angle. For example, the sine of theta is the cosine of 90 degrees or pi over 2 minus theta. So 2 angles are complementary if they add to 90 degrees. So these 2, theta and pi over 2 minus theta, would add up to pi over 2 or 90 degrees. And so this is the sine of the complementary angle, which is why if we go down the chart and we write in values for the sine, we can go up the chart and write in values of the cosine, likewise with the tangent and cotangent and so on. Because what actually happens is the cosine is actually, the sine and the cosine take opposite meanings when we go to the opposite angle. So here we have our triangles, and notice the complementary angles, A and B, or A and D. And what's adjacent to A is opposite of what's adjacent to B. And so this is adjacent. D, this is the adjacent side. Now, we can extend this to 4 triangles. And if this is theta here, this is 180 degrees, so pi minus theta. This is pi plus theta. And this is 2 pi minus theta. And so these triangles all operate just like this one, except here's the tricky part. We're not really talking about the sides of the triangles in a sense, because there's no such thing as a negative side. But those x's and y's can become negative depending upon which quadrant you're in. So in the second quadrant, x is negative, y is positive. In the third quadrant, both x and y are negative. In the fourth quadrant, x is positive and y is negative. So your trig functions may be negative in some of these quadrants. And it actually matters with tangents whether you have a positive over positive or negative over negative, for example. And that'll come up later in another video. That's a little more advanced to just get started. For angles not in the first quadrant, we use the sine, S-I-G-N, the sines of x and y. Or is always done negative, because it's done as the square root of x squared plus y squared. So that's always done negative. Well, triangles do not have negative sides, trig functions can. Okay, so now we'll talk about the Pythagorean identities. There are 3 Pythagorean identities, and I'm not going to worry about shuffling the order to the way you normally see them. If you're in trig, you should be able to readjust the order of terms. Well, we start off with the Pythagorean theorem, r squared equals x squared plus y squared. And then we divide by r squared. And we end up with 1 equals, now this is 1, the cosine is x over r, the cosine square, plus y over r, sine square. That's normal, and we usually see that as sine square plus cosine square equals 1. As I said, I'm not going to rearrange them here. I'll expect you should be able to do that. And as we're getting close to finishing up this video, I'll ask you to please consider hitting the subscribe button and joining the playlist, actually, for trig, because I'll be adding more. We start with the same Pythagorean, and then how we can divide by x squared. So r over x is the secant. So secant square equals x over x is 1. And y over x is the tangent. So secant square equals 1 plus the tangent square. And we can divide by y squared. Y over r is the cosecant, so I have the cosecant square. X over y is cotangent, so I get the cotangent squared. Y over y is 1. Now, I wrote these in the opposite order, just because I was cloning the form of this one. But you can think of it as a cotangent squared plus 1. And really, it doesn't matter. The order of addition does not really matter. Well, thank you for watching, and I have other videos some through calculus and a few differential equations even. So consider some of the others, and thank you. Okay,